Okay, so now let us look at the properties of the rational numbers. Now we will begin our discussion with the closure property. Now, if you recollect, closure property simply means that given two numbers, let us say A and B, what happens when we add, subtract, multiply, or divide any two same type of numbers? What is the result? Is the result the same number or not? So that is what the closure property is. And what I have over here is a table which says, so the first column actually gives us the numbers, the different types of numbers. So we will also be reviewing the closure property for natural numbers, the whole numbers, the integers, and then the rational numbers is what we are going to kind of add to our already existing knowledge about the closure property for the other three numbers that we know about. And what we will do is we study the closure property for the four basic operations, that is addition, subtraction, multiplication, and division. Okay, so let us look at addition. Now, the condition for closure property under addition is add any two numbers, that is A and B, and then see the result. So what we have already discussed in earlier classes, that when you add any two natural numbers, the result is always a natural number, which means we say that natural numbers are closed under addition. Similarly, whole numbers, whenever you add any two whole numbers, they will always give a result which is a whole number. Hence, whole numbers are closed under addition. And you can similarly conclude for integers. So we have covered all of this in the earlier chapter. Now for the rational numbers, and we are going to prove this. So the same thing applies to rational numbers. If we add any two rational numbers, the result is always going to be a rational numbers. So the rational numbers are closed under addition. Now to kind of conclude the closure property for the four numbers, that is all the four number systems or all the four types of numbers, natural, whole, integers, and rational, they are all closed under addition. You can see all of them are closed under addition. Now let us look at the third column, that is subtraction. Okay, so the criteria for subtraction is we take any two numbers of the same type, that is A and B, either natural or whole or integers or rational, and we subtract the two numbers and we see, check what is the result. Now, what we have concluded earlier for the closure property of subtraction for natural numbers is that the natural and the whole numbers are not closed under subtraction, which means that when you subtract two natural numbers, it is not necessary that the result of this subtraction will always be either a natural number or a whole number. So they are not closed under subtraction. But we did find out that when we subtract two integers, the answer or the result is always an integer. Hence, integers are closed under subtraction. And we will conclude the same for rational numbers, that rational numbers observe the closure property under subtraction, the operation of subtraction. So to conclude the closure property for subtraction, we can say that the natural and the whole numbers are not closed under subtraction, whereas integers and rational numbers are closed under subtraction. Okay, now let us look at the closure property under the operation of multiplication. We follow the same principle. What we do is we take any two numbers and see A and B and see the result of multiplication. And what we find is that for all the four numbers, that is natural numbers, whole numbers, integers, and rational numbers, you can see that whenever you multiply any of these two type of numbers, you always get that type of number. So let's say if we take rational numbers, you can take any two rational numbers and you can prove it for yourself. And we will actually be doing an example in the next video. Whenever you multiply any two rational numbers, the result of this multiplication is always going to be a rational number, and hence we say or we conclude that rational numbers are closed under the property of multiplication. Now let us look at division, and you can see that the division column has all no's. So what we do is we just take any two type of numbers. So let's say we take any two natural numbers, just divide them, and then we see whether the result of the division is it a natural number or not. And what we find is that all these four types of numbers, that is natural, whole, integers and rational, they are not closed under division, which means whenever you divide two numbers of the same type, that is either whole or integers or two rational numbers, the result will not necessarily be that same type of number, and we will prove this later on. Now just a quick thing to note: if you look at the natural and the whole numbers, you can see that whatever is the closure property for natural numbers is the same for whole numbers, because the only difference between natural and whole is the addition of a zero. Okay, so I think that is straightforward to remember. It is the integers, as you can see that integers and rational numbers, again they have the same properties under the closure. You can see that both of these rows, for integers and for rational numbers, they are same. Okay, so in the next video we will try to prove the closure property for the rational numbers. That is, we will look at trying to prove the statements that we have made over here about addition, subtraction, multiplication and division of rational numbers.